he's talking to like the Swedish banker, the Swiss banker, and the guy's like, Jordan, Swiss custom requires 10 minutes of customary chit chat, and it cuts to like what they're actually thinking, and he's like, just talk to me, you Swiss pig. And the guy's like, I know, you American rat. And then they like actually start talking business. They like sit in awkward silence for 20 seconds and then just start talking.
Lord.
And it's one of my favorite scenes from that movie. What a good movie. What a freaking movie. Yeah, here, hold on, let me I'm gonna record this meeting if that's okay with you guys, just to like I guess the others Ashley and the others want to be able to see it. But yeah. No, so you've been good? That's good.
Yeah. I've just been working on my other project for class.
Oh, nice. Very nice.
And managing a restaurant and all that shit,
Oh, shit.
Oh, damn.
Yeah. Oh, damn is right. That's it's quite... Wow.
It's so much worse being a manager compared to being the guy at the register. Because
yeah,
at least at the register, you can just kind of like not give a fuck, and then they'll call for the manager anyway, and then I gotta walk up there and be like, and actually care, like, hi, how you doing? What do you want? Why are you yelling at my employees?
Gotta do stuff now.
Yeah, if there's an issue, just go get the manager. Well, the manager doesn't have a manager, or they do, but it takes way more fucking time to get that guy.
Yeah. It sounds like a bit of a grind. That's good though. I mean, that as long as you feel fulfilled, right? 3D modeling your mom. I just saw that. Very nice. Very
nice. Oh yeah, that's coming along great too.
Excellent. Oh, excellent. Yeah. Model me like one of your French girls. Yeah. Nice. Cool. Yeah, I don't. So honestly, going into this today, I don't have like a super clear plan. But I doing more of like last time, reflecting on the goals that we set, reflecting on where everyone's at, what people's thoughts are on the stuff that they've worked on. Like, are you enjoying exploring XYZ area of game development? Do you think that you'd be more interested in doing something else? And like, what did you accomplish since last weekend would be pretty cool. I know Trevor, I think, attended some of my lectures on yesterday.
Oh.
But what?
I said all. I was there the whole 5 hours.
Yeah,
it was a lot, but it was good.
It's kind of wild. I'm impressed. They weren't as well structured as usual because I just didn't sleep well prior, so I was I stuttered a lot.
I mean, even then, you covered like a lot, like everything that needed to be said. I think.
Covering a lot isn't, that doesn't equate to being a good teacher.
Yeah.
But I appreciate
there was a lot to cover, and I think you did cover a lot, and you gave like, a good amount of explanation. If anything, if needed, you can kind of slow down the recording, go back, see what you need.
That's true. Yeah. I have to take that into account.
That's the beauty of recordings.
That's fair. I wish I had allocated more time to organizing myself. This last week has been a little bit busier, and the week prior, I just wasn't very productive. Admittedly, I had some things came up, but yeah.
Preaching to the choir.
Yeah, same here.
Yeah. That's life. We're all of us are stretching ourselves, but I don't think I'd be satisfied if I wasn't pushing my limits as to how much I can try to do in a.
Amen.
So. Let me look at the spreadsheet from last time. We got, here we go. Nay can do Blender and Unreal Engine, wants to do more Unreal Engine, especially gameplay programming. And you said you'd explore the action RPG thing. You feel like you're at the point where you understand some blueprint, but you don't understand maybe most of what's going on, which is fine. Do you want to like share your screen and try to like break down the project? Would that be cool? Like, do you want to,
I wouldn't be able to do that at all.
You don't want to like try to walk.
When I tell you, I am not quite sure what the hell is happening. I really don't.
Okay.
But
no. Well, do you want to?
Sorry, give me 1 second.
Go ahead. Go ahead.
My
No,
mom's calling me. Hold on.
you're good. You're good. I can move on to someone
Look
else.
at that fire ringtone.
Is that marimba or xylophone?
I have no idea. It's something.
Cool. I know Trevor. You told me you weren't able to hit exactly your goals, but you decided to explore more gray boxing stuff, and you did do the stuff during the level design thing yesterday, which was pretty cool.
Yeah, so I was following along with like a bit of the stuff. I mean, whenever we all gave our examples, clearly I got a little distracted. But I
No,
think I
no.
think the general concept of making an outline was kind of there. I had to make a plan.
I did that. I mean, that's not part of like level design.
Yeah,
That
yeah,
was just
level
like me
design,
trying to get people. I wanted to put you in the shoes of someone that
Mhm.
the starting gun just went off, and you're in the first like hour of the game
Yeah.
jam, and you're talking with your team about like how everything's gonna work,
Mhm.
and you have to dream up like a level, and then you have to like really quickly move to the design phase and then Unreal Engine.
Mhm.
So I wanted to put you in that position. That was the goal of that exercise. So
I don't think I'm terrible with coming up with game ideas, but I think making
oh.
like practical game ideas might be a little further down.
Practicality comes with experience.
Oh
It's
yeah.
good to have someone on your team that has the experience to tell you what is and isn't doable and
Mhm.
can like help you navigate scope. Because it's not easy to do when you don't have experience. You'll go for ideas that are like maybe well outside your abilities.
Let's make another Dark Souls.
Yeah. Dude, my
In
idea was
2 days.
ridiculous. My like LinkedIn like crowds hunting down
Dude,
thing.
that one, I still really like that.
I thought it
I
was
almost like want
clever.
to do that. I
So
like it.
I thought it was clever, but like it would require
Mhm.
a
It's not
good
something that you can do quickly.
well no listen drawing up the town
Yeah.
is faster than you think. The challenges are like setting up a nav mesh and
Mhm.
actually like setting up the AI behavior in a
Mhm.
interesting way such that they like actually they go to the
Yeah.
store, they work their jobs, and then they come home at the end of the day, and then making it all like look half decent. I don't.
Mhm.
There's certain. I haven't worked with large NPC crowds in Unreal Engine before,
Mhm.
and I mean that's a challenging side of gameplay programming.
Yeah.
Crowds and combining crowds with navigation and making a world feel
Mhm.
alive is
Yeah, with like
not
a nav map and
you don't just like snap your fingers and like shit out Assassin's Creed where there's like all these NPCs like interacting with each other and having a
yeah.
good time, and they have like funny dialogue, and as you walk past them they go
And then
like,
your
hey,
player can go hide in them.
yeah. That like Assassin's Creed has iteratively improved its NPC system like game to game, and I'm sure they reuse
Mhm.
code between their games and keep like improving on it. It is the product of like years of effort, and
Yeah.
to produce an environment that is that dense and interesting is not trivial. To make
Mhm.
it for a game jam with like a really low, at a low quality with like low poly art and stuff is like
Yeah.
borderline doable. Like
Yeah.
you want to hope there's someone
You're
on your
cutting it
team
close.
that's experienced with the associated like sides of Unreal, because Unreal has a framework for that. But anyways, I'm rambling. My point is, yeah, scope creep is definitely something hard to do, and
Mhm.
you gotta work around it. It's tricky.
Yeah. I mean, I will say though, like even with games like that, right? I know there was this one game that had like it was like made for a game jam. I can't remember what it was, but it was supposed to be like a Souls like,
Uh huh.
but it was with bugs
Mm.
and like the entire like game's aesthetic looked like super I can't like use the word, but it looked like RuneScape, right? Like where it's all those pixels and it is
I
3D and
can't
moving,
use the
but
word. You can say shitty. This isn't like what's
No, because I know it's like crunchy or something. There's like a
oh
literal word that you use to describe it, but I can't
oh
remember. Maybe it's crunchy. I don't know.
JPEG'd.
Yeah, like JPEG. No, but
Yeah.
it's almost like its own comfy aesthetic, almost like how Borderlands is. Like
Oh,
it looks bad in a general sense, right? Like when
but
you
it's part
compare
of the
it to
aesthetic.
4K
Yeah.
graphics, but it's an aesthetic that has like a purpose. And so the game it looked like that, and it was centered around like bugs, but it was a Dark Souls game, and so it had like the same kind of combat setup, and it wasn't very long. It was like maybe an hour's worth of gameplay at most, maybe more like 30 minutes, right? But it was basically like that big kind of game design kind of put on a much smaller scale, right? So you're taking that same general idea, like how what you had, right, is a small world. You have this town, and you go and meet people. I don't think it's a bad game jam design, because I think if anything, for a game jam, you might just make a smaller version of it. Of maybe you only meet up to like 3 people versus like a full-on
Yeah.
game where it might be like 50.
Yeah.
Just
No, you only have to
crazy
make
amount.
a couple of NPCs, but then it becomes more of a collectathon, and it becomes like then an interesting search.
Mhm,
But yes, and I agree. If we're talking about like game design theory,
mhm,
when it comes to game jams, it's very good to pick an idea that can be incrementally implemented, so that if you
mhm.
shoot for the stars, you land on the moon, kind of deal.
Yeah,
Yeah. Uh, but yeah, no,
I mean that's not. I was gonna
it's
say. Oh yeah, what? Go ahead.
no, go ahead, go ahead. I don't think I
All right.
have anything to add. Sorry.
Yeah, so I feel like, I mean, this is just like me as an outsider. I've never done a game jam, so I really don't know. I'm kind of talking out of my ass. But
Uh-huh.
that being said, from my understanding, sometimes what people have done with game jams is they've used that as an opportunity to kind of force themselves to come up with an idea, and then they
Yeah.
come up with that kind of incremental idea, and they go and, like you said, shoot for the stars, land on the moon, and it becomes, that game becomes like a proof of concept, right? Like,
Yeah,
okay, we
yeah.
know that we can do this, so what if we go and move this into maybe a bigger project? Maybe
Yeah,
we
yeah.
change some of the stories, some of the aspects, and make it,
They spend
a
the
game.
following months building a launch pad on the moon. Yeah, and then
Yeah.
ultimately
A launch pad on the moon.
yeah, ultimately land in like another star system. Yeah.
Hmm.
Yeah, no, that happens. That happens a lot. A lot of really, really successful games have come out of like ridiculous game jam ideas.
Hmm.
But yeah, finding a dedicated team and good execution is really important. It's not easy. But yes,
Hmm.
that's you're absolutely right. Um, yeah, there we go. Yeah. Anyways, sorry. So, since last time, yeah, you did some of the gray boxing. Logan, what have you been up
Ah,
to? You the crop out sample project. Did you explore it? Do you feel like you?
I've looked around it. It's a little bit above where I'm at right now, so I took a look at some of the
Oh,
the other samples that they had.
sure.
The one I ended up getting some level of success with was the vehicle
Oh,
sample project. Just like
interesting.
tweaking the random settings, seeing how everything flows in between it, just getting
Yeah.
a feel for everything before I jump to something where it's like all built up and actually running.
Oh, that's
But
good.
that's my next step is to get back to the crop out sample project. To,
That's awesome. That's really good. I'm glad. No, crop out is definitely one of the more advanced samples. I figured I'd throw you in the deep end, but like,
yeah, no,
um,
I appreciate the I don't
there's
know the enthusiasm.
there's a 45-minute video on the Unreal Engine. I don't know if I like DM'd it to you or if I just like left you hanging, but there's a like Unreal Engine has a YouTube channel and no one subscribes to it. It has like no viewers or subscribers. Every video that they make gets like 3 likes. But they actually put together like 2 hour high quality like walkthroughs of their samples and stuff. It's really
Okay.
cool. And they interview like interesting developers that are doing unique things with Unreal. Um, so they have a walkthrough of the crop out sample, and it's 41 minutes, and they
Ninja
have
again.
like one of the creators like step through the blueprints and kind of talk about um, what's going on and like how it's
Oh
being
yeah, I found it.
done. Yeah,
I'll add that to my
nice.
bookmarks.
It's just 45 minutes, which is like pretty tolerable for a video.
Yeah, that's
Um,
pretty good.
and they take it on at a pretty low level. They cover everything from like how some of the models were optimized to some of the like gameplay structure to the procedural generation of the islands. And they I think they start covering AI around the 25-minute mark. I see there's like a data table here, and they break down like the tasks that all the AIs have and how they prioritize tasks.
Gotcha.
Yeah, it's
Yeah,
cool.
I was able to get far enough in that I could figure out the generation of the island, but by the time I got to the AI, I was just like all over my head.
Really? Okay, wait, island generation is not an easy part. They use a plugin. There's like a whole system written in like Python that's a Unreal plugin that's
The
being
way they have it implemented, at least in the most recent version of Crop Out, is they
uh
just have, at least for that main island, the way they do it is they just have a bunch of cones that they chop the top off of and then just like randomly arrange those and then merge them together.
Ah, I see. Okay, yeah, that makes sense.
Yeah,
That's pretty cool.
it's
That's pretty
it's,
cool.
it's pretty easy.
Very nice. Yeah, you
Yeah,
can definitely do like runtime procedurally generated meshes in Unreal. So I feel like it's probably in that.
that's something I've been looking into and doing in Unity, but have had limited results. So I'm curious how it'll work out with Unreal.
Meshes are computationally expensive, right?
That's the thing.
That's the thing. If there's simple meshes, that's fine. But if you're working with like thousands of points worth of proc gen, like don't build your entire world out of a procedural mesh generator
Right.
because it's gonna lack a lot of the features that are meant for more standard meshes like LOD
Yeah.
systems. I don't know, whatever.
Right.
Cool. No, that's good. That's good. Yeah, if you're interested in proc gen, I've been doing a lot of proc gen research lately. So you let me know and we can talk. But
All right.
that's
I'll
good.
let you know when I'm comfortable enough to kind of expand to that point.
Yeah, yeah. It's gonna be some time. Gonna be some time.
Yeah.
But proc gen's like the cream of the crop.
Yeah, it's
So it's
so
some of
cool.
the harder stuff, but it's very exciting. Um, I don't even know how to best approach it in Unreal for a lot of things. But anyways, so good. Okay, well that's good though. I mean, you explored the vehicle sample. That's good. Do you? Yeah. What are our next steps here then? Are you guys all happy with like the things that you've been like vaguely tasked to go in the direction
Yeah.
of exploring? Or
I know I'm still good. I've still got a plenty large to-do list on my part.
okay. No, I'm not so much about like do you still have things to do, rather like are you happy with the direction that you've chosen? Like is
Oh yeah, yeah.
exploring okay, so
Yes, sir.
yeah, okay. Cool. So Nay, you're sticking to like yeah, gameplay programming. Logan is sticking to like I guess yeah, AI and gameplay programming. Uh Trevor is are you Trevor, do you still want to be like committed to level design and gray boxing? Is there like another direction you want to go
Uh,
in by
yeah.
any
I mean, I
chance?
haven't really. I don't think I've really given gray boxing like
A
a
full
proper try. I've just kind of like I know what it is now.
for
I
what
think I
it's
need to do a bit more because like I said, I've had
mhm,
a busy week, so I haven't really gotten to
that's
explore
okay.
a whole lot. But
For what it's worth, gray boxing is more of like a like uh a highly committed development like practice. Like
yeah,
if you're in some project for the long run, you gray box the levels first. The gray boxes get sent to like an artist that
yeah,
fills them in. Game jams are not really an environment to like quote unquote gray box in. During the game jam, the direction that you're going in right now is like using the Unreal editor to build levels, not just the
mhm,
BSP brushes. We're talking the landscape system, the lighting system, a lot of
yeah.
the
That was a lot
technical.
more of what I was messing with. I was like
Exactly.
making the landscape and
We can
putting textures on it.
I can definitely guide you through landscape shaders. That is like a whole area, like how to build
Hmm.
landscape materials properly. You can compartmentalize them. So like yesterday I showed how you might remember I collapsed the material attributes into one node so we could use a single blend
Hmm.
between like three different like material attribute sets. But you can take it a step further and you can create material functions, which are like a material packaged into a single node. And then you create a material function for every layer, like one for grass, one for sand, one for dirt, one whatever. And then
Hmm.
you just plug in the material functions in like the main landscape material. And it gives you a lot more control and usability. You get to like actually treat grass like it's its own independent asset when you can
Oh,
open it in
okay.
a separate editor. Like there's I'm saying there's even more to the that
Yeah,
we could
there's
do.
more options available.
Yeah. Yeah. So you guys know, actually, while we're here, I'll advertise a little something. The clubs haven't really announced it yet, but we had a meeting with the branch leaders. Logan was there because he's
Yep.
kind of the FIT lead, and where is it? Wargames meeting. There's here we go. Um, oh, Alec made an ad. That's cool.
It's
There's
so
a.
good.
I will look at that. I have not seen it yet. Alec is so talented. I love him. Um, This right here, I'm going to drop it in the general chat, kind of inconspicuously. You guys get first access, but if anyone notices, they're welcome to use it. This is a form to submit ideas for the jam theme, and when the day of the game jam comes around, we're going to spin a wheel and pick one randomly from the list of submissions. So, while we're here today, I wanted to give you guys the opportunity. Oh, hey, Mike.
Yeah.
What's up, Mike?
The enemy is on our soil.
Oh, a German just walked into the room.
Oh man, hello, Mike. I was so you guys, if you have like game jam theme ideas, kind of like the ones that we randomly came up with yesterday during the level design thing, if you remember, Trevor, like spam them into this form. Like keep resubmitting this form. Yeah. I'm saying like do multiple
ones.
Make multiple submissions to the form. We intentionally make it so that you can like click. I'd like to submit another idea.
Just gonna put caves in there 100 times.
we're gonna remove duplicates.
Okay, good.
So yeah, I thought of that. I was like, someone could really skew this. Caverns, caves, caverns. Caverns, underground tunnels under the ground. hole in the dirt, hole in the stone.
Hollowed out rock.
Hollowed out rock. Oh man. Subterranean. Yeah. Anyways, if you're clever and you do like subtly different words, we'll keep them around, I guess. We'll use our discretion.
Just don't be a pain in the ass. That's annoying.
Whatever. Like I won't.
Yeah.
It's anonymous. If you do it,
Wait,
now
is
it is. But if you, it's anonymous.
It tells me to use my email.
Really? What? Oh fuck! Hold on.
I think so.
It might just be Google enforcing it. It says switch account.
Yeah, anonymous in public.
But it's not. No, I wrote the anonymous in public.
Oh yeah, it says not shared. Okay.
Not shared. Yeah, exactly. It's just taking. That's just Google being precautionary. I think. Let me look at the.
Making sure you exist and you're not a robot.
Yeah, collect email addresses. Do not collect. Yeah, I have that disabled. So.
Yeah, you gotta have a CAPTCHA on.
Yeah, so I mean God, yeah, I don't really know what to what to make of this meeting. I mean, do you guys want to attempt to collaborate on anything? Maybe I try to walk through the Cropout demo and explain like things about it, or perhaps the ARPG demo. And we could talk about some of the like level editing tooling as well to satisfy that side of things for you, Trevor. Like, what would you guys? We want to spend our time here doing? I mean, it's 4:45. Like I'm not gonna lie, I'm pretty sleepy. I slept like 2.5 hours last night. If we wanted to, if we wanted to call it a day, I'd also be open to that. But that would feel kind of bad. What are we feeling?
I, for one, am good, but if anybody else wants to go over something, I will stay because any bit helps.
Sure.
Yeah.
Oh, I see you've got the ARPG demo up. Damn, that is dense. There's a lot going on here. Wow.
Oh yeah.
Okay.
Yeah.
Woo.
I mean, me and myself, I'd be down for like a walkthrough of like what's happening. I was playing a little bit of it. It's pretty cool.
Damn.
Like
Oh my
just for
God.
starters,
Cinematics.
Oh my gosh.
just for starters, I wanted to
I love that.
figure out how to edit the curve tables for like the amount of damage each character can do.
Okay.
Like mine and like the enemies and stuff. But when I click on it, it doesn't seem editable.
Oh.
Unless I do it somewhere else.
Yeah. I also noticed that you're in Unreal 4. What I'm gonna do is I'm gonna clone the project and then transfer it to Unreal 5 and see what happens. And I'll give you my best demo. Let's do this. I would be so down. Let's today we're going to fuck with the ARPG demo.
Bro, this is bootleg Kratos they put in here, bro. It's crazy.
So is this an Unreal demo? Or
Yeah.
is this one you guys made?
Yeah, it's a sample project.
We actually made this. You should be
We
quaking.
made this in the last.
Quaking.
I was about to
Half an
say,
hour.
if one of you made if one of you
You
made
should be
this, this
you
is
should
very
be
well done.
shaking right now, Mike. You have no idea what I've trained them to do. No, you don't know how capable they are.
When you first played it, I'm like, okay, this looks makeable. And then when the cutscene introducing the enemies zoomed in on the enemies, I'm like, oh wow,
Yeah.
that's something, all right.
Wait a minute. Well, what is that scurry that bro did?
Oh, it's part of his running animation. Shit, where'd it go?
Bro scurried.
Animations.
All right.
That's the boss. Wait
Oh
a
yeah,
minute.
so Michael, I
yeah.
mean, I don't know if I'm trying to get too much into it today because I got
Get
I
some
got
work.
this lab that's due by the end of the day, and I mean,
Sure.
like you said, you're tired. And then I got like a quiz or something due tomorrow, but for like most of the rest of this week, I'm like kind of available. If you ever find yourself maybe with some free time, if you're open to it, just let me know. I'd like to go over maybe some level design if possible.
Okay. I would
Unless
prefer.
you're busy.
Well, here's the thing. Here's the thing, man. I'm pretty perpetually busy. But if you
Okay.
can, on the flip side, if you can instead reach out to me, there's a much higher chance that I will reply.
Okay.
But the other way around, I'm not gonna like. I'll prioritize now because that's the meeting time that we like agreed on.
Gotcha.
But if it's, I I'd rather. I'm already.
You're already
Like
planning out for this.
I don't want you. Yeah, I don't like. Don't take this the wrong way. I care
Mm-hmm.
and I want to help, but I feel like I'm already doing a lot by like
Oh yeah, to be
originally.
reaching out to me, it's a lot. Yeah.
I mean, originally those lectures, the ones that are on like
Yeah.
Saturdays, they were meant for FAU FIT, and because FAU
Mhm.
FIT can't like generally make those times, I am
Mhm.
here right now on Sunday, like, and I'm about to spend the next like hour burning through this demo for you guys. Like I'm going out of my way to make time for this, but I don't want to make even more time just to work with you one on one.
Oh yeah, no,
I
I
will
understand. I mean, that's why I
happily-
was just asking. If you don't have time, then that's okay too.
I'll happily work with you one on one to solve a problem, to answer a question. I'll give you like 30
Mhm.
minutes, but I'm not going to sit down with you for 2 hours to explain the ARPG demo at like on
Yeah.
Wednesday or something.
Yeah.
Like, and don't take that the wrong way, right? Like, I obviously
Yeah.
I care. You understand.
You can't do it
Mhm.
for me. Yeah, I
Yeah.
got you.
Okay, all right.
I'm gonna go and let you all collude. Bye bye.
Bye.
I just wanted to-
Collude. Collude.
Collude.
FAU FIT collusion. Mm.
Okay, goodbye.
The game jam was rigged. See ya.
Right from the start.
Oh my god.
All right. Let's do this. Here we go. 5.3. All right. I am launching. Oh boy. Here we go. Okay. I'm gonna start sharing my screen.
Mm-hmm.
And I'm converting it over to Unreal Engine 5. We'll see how this goes. Totally unrelated note. Any of you guys watched Ghost in the Shell?
Mm-mm.
Dang.
Weirdly enough, I think I watched some of it, but not like the whole thing.
I see.
Just like family was watching it, and I kind of,
the anime or the new movie?
the movie.
Gotcha. The movie was not very well received in the United States compared to like how well received it was in Japan and Korea.
Mm-hmm.
But because the anime is like really special, like it's
Yeah.
regarded as one of the like top like most notable, significant, whatever. Anyways, yeah, hold on. Unreal's giving me a hard time. Oh boy. Oh boy. All right, let's try this again. I'm trying to force this thing open, but it's
What is that? Lidl.
maybe if you showed up yesterday, you'd know.
Hey, bro, look, I was in that restaurant all day, bro.
Maybe
I
if you
didn't
were-
get home till like 11 at
I'm
night.
so sorry. I don't blame you. I'm sorry. But
You should definitely check out the videos.
Yeah, I check out the YouTube videos first whenever I have the time.
Mm-hmm.
And then I also have those courses that I'm still trying to go through on Udemy.
Yeah.
it seems I am. Wow. Yeah, I am unable to launch Action RPG, because it's in. Yeah, the attempt to convert it did not work. It's not happy.
The jump might be too far.
Yeah, I think we're going from. I mean that's kind of crazy actually. I'm just it's not happening. Okay. Alternatively, what I can do is I can do the crop out sample project. You guys or any sample project. Honestly, we got there's an
Yeah.
FPS game here. There's the city sample is pretty wild. We could do content examples. Oh wow, yeah. There's gonna be some beautiful stuff here. Um, Stack O Bot, a small sandbox project that showcases a lean player controller, an expandable interaction system, and modular pieces that you can build on. Interesting. What do you guys what are we thinking? Elemental demo, matinee, particle effects, platform.
And I'm down for crop out.
Yeah.
Yeah, Cropout is their most recent sample, so I expect it to be one of the highest quality ones. That's why I'm interested.
Mhm.
All right, Cropout time. Cropout go
Nice.
burr.
I'll go bird.
Mhm.
Okay, here we go. Yeah, I mean, there's a lot of good content here. This city sample shows how to use Unreal Engine's like. There's a thing called ECS, which is like a way of coding in Unity that keeps data close to related data on the CPU cache and allows you to do extremely performant, like multi-threaded operations for like massively, just like massive worlds and stuff. And the Unreal Engine equivalent is something called entity mass entity. It's called mass entity, and this city sample is like a giant, like functioning city from like Houdini that is exported as a point cloud, and then Unreal Engine populates it with like AI and cars that drive around and walk around, and it's like a fully simulated massive city.
Whoa.
That's crazy.
I've always wanted to look at it, so honestly, I'm going to download it because there's a project I'm working on that has related issues. So maybe I can learn something from this. That would be exciting. Sure. All right. Bam. Library. Crop out. Let's crack this sucker open. You'll notice that they have a nice thumbnail for it. Honestly, having a thumbnail on projects makes them feel so much more legitimate. Like this right here, or this one, like very satisfying. Very satisfying thumbnails. This highly unsatisfying. Super Florida Man, not that exciting. Stacked Cities needs a thumbnail as well. But yeah, man. All right, it's launching on my other monitor. 5,000 shaders to compile. Oh god.
My background cycle?
What?
Does your background like cycle between things?
Yeah.
Change it every day. Oh.
I've got a folder. Oh, this is
Okay.
actually the one that I wanted to show. This is a project that I'm currently working on.
Nice.
But the old graphics designer for the UF Game Developers Association before we were Devil Up created this. It was like originally was a club-wide project, but it got abandoned, and I've since taken over because it's like so inspiring to me. It's a really cool idea. We're making like a I have no time to work on this, but this is why I slept 2.5 hours last night. I just went on this crazy binge where I listened to the Ghost in the Shell soundtrack and like studied proc gen from 1 a.m. to 8 a.m.
Oh my god!
And this is we're trying to make like a. It's like the future, and everything is ultra capitalist, and like the poor live in like the slums, and there's these huge towers that we're calling like vertical cities, and they're the towers have like the entire population of like Manhattan in one massive like huge skyscraper, and it's like socioeconomically stratified, and you're sort of doing like this heist through it, but it's procedurally generated and like co-op, and like what a grind. I can't make all these claims. I have actually like next to nothing to show, but
Yeah,
I've got the basics working. We've got the basics working. Camera controls, multiplayer, a little bit of each. But
are the towers connected at the top?
no, they're just like huge individual mega structures. But
The rich people have to walk through the bottom.
Yeah. No, I don't think the rich people ever go down. The rich people like live up top in like high security like utopia, and
Helicopter from building to building.
not even like they're so high altitude that the rooms are pressurized. Like,
Oh wow.
yeah. And the idea is like it's in a near future where infinite energy is like very viable with like fission or fusion. Um,
Hmm.
but like, sorry, I'm gonna expound on this while we wait for everything to load.
Yeah, go for
Um,
it.
um, yeah, near future, but the like core technologies that we're focusing on is like AI is a thing. Um, something called white steel, which is just like
Hello, Ashley.
this super. Oh, is Ashley in? Hey, Ashley. Ashley, you've missed like nothing. We're actually like about to start like doing something meaningful. I'm gonna
Oh,
explore an engine demo.
okay, perfect. Perfect.
Yeah. We did talk a little bit. Actually, since we didn't talk last week, yeah, I'm gonna start expounding on my sample project thing and ask you a little bit. How are you? First of all, how's it going? How you
I'm
been?
good. Everything's
Nice,
good.
nice. I know you were busy last week. I know I think I messaged you about like what I would like you to try to do. I gave
Yeah.
you like your mission should you choose to accept it. Um,
Mm-hmm.
I was under the impression that you're interested in modeling. Is that correct?
Yeah,
That
I'm interested.
is that the like main thing you're interested in? We kind of all set like directions or goals for ourselves last time, and I think I oh no wait I had this conversation with you. I forgot VFX, UI, and you said yeah actually sorry you ended up
Yeah,
saying that you were interested in learning VFX and UI. That's right.
right. So initially I was like, modeling's cool. Yeah,
Okay. Okay. So
I'd be interested in that.
modeling VFX and UI. I'll try to. What I'm about to do is I'm going to walk through an Unreal Engine sample project, and I'm going to try to pick out parts of it that are relevant to all of us to hopefully like learn something from it. But
Okay.
that's I did I ever give you like a idea for what to work on? Oh, I gave you the content examples. Did you end
Yeah,
up looking into those? Did you like download anything? And
yeah. So we said
nice.
like I could take a look at like UI for this weekend, and then I can take a look at VFX. I think that's what it's called for
Right.
next weekend. Cause kind of like a lot to like look
It
into
is.
for
It is a lot.
a one week.
Yeah.
So
Yeah.
yeah, I took a little look at the website. I scrolled through it, and I tried to download Unreal Engine. Like that's the first thing I tried to do, and it took like
Right.
a long time, and I never even got the software to open yet.
No.
But I
Oh
finally
no.
finished downloading.
Okay, that's definitely a first step. Yeah, you gotta.
Yeah,
So,
I haven't done anything inside of like actual program yet.
oh, that's okay. That's all right. Yeah, download. So, what you're gonna do, right? You download the Epic Games launcher. I'm sure you've already done that.
Yeah.
And then right, we got Unreal Engine over here. The thing that you have to do is you go to samples and you scroll down until you find I think it's called content examples. Content exam. It's somewhere here. There's UE feature samples, content examples right here. And this pack right here is a single project file with like 10 maps on it, and each map is like a hallway of it looks like a museum, and it's a museum showcasing like different Logan, you got a bit of I can hear your roommates very clearly, I think.
Yeah.
I'm sorry. I'm so sorry. Okay. Yeah, so each of these here, I'll go ahead and generate a project just to like give you a glance while I'm waiting for the other one to open. I'm currently in the process of compiling shaders for another project, so
Okay.
I'll just go ahead and this is a much lighter weight project, so it's a good opportunity to show off some of the features and things. But yeah, this content examples map is it's just a hallway that showcases all the different like functionality of Unreal Engine, and it's organized. So there's like a map dedicated to animation tools. There's a map dedicated to particle systems, so that would be like the VFX stuff. There's a map dedicated to UI. So the link that I gave you specifically highlights um, the UMG map. So the UMG map talks about user interfaces for your game, sliders, buttons, progress bars, and more. I actually explored UI this yesterday. It was the last.
Yesterday,
It was the
yeah, I
last
was
like
there.
yeah.
I saw the Patrick game. It was really interesting.
Right. Yeah, I definitely floundered around a little bit because I hadn't slept well, which is funny because I slept way worse last night, and yet I'm way more like lucid right now. So, but yeah, yeah.
Yeah. No, but you said a lot about like how to add like the health bar and like uh crosshair and stuff like that.
Uh-huh.
Yeah,
So
Patrick got a
that was
health bar and got shot to death and fell through the map.
Yeah, yep. I don't know if you saw what just happened. The city sample was 94 gigabytes, the like Matrix city that I was talking about, and it was
Oh, and it was
it
downloading
was
first.
downloading. So I was like, nope, screw that. Yeah. Oh, and the project finally opened. Okay, we're gonna focus on Cropout, but I'll talk about the UI in here a little bit, given the opportunity. Let me put this down here, and let me. I'm gonna also. Are you guys looking at my stream on 1080p monitors or perhaps 1440p monitors? Is there
I'm on
I'm on my
1440.
phone right now.
wildly differing responses? That phone
I'm
1080.
1080. Okay, all right. We'll work with 1080. I was just
We have the Spectrum.
I would have been down to share my screen at like a different resolution to make it a little bit I don't know. I feel like Unreal Engine's a little too fat with the UI sometimes, and I prefer
Yeah.
working on my 1440p monitor. There is a way if you go into tools, debug, widget reflector, you can change the GUI scale in here. So something like 0.8 honestly feels pretty good
What?
at
Do
1080p.
that again?
It's the GUI scale.
Huh.
It's just a slider.
Wait, how'd you get there? You said window and what?
Tools, debug, widget reflector, which is so random. It's so random because it's not like you're not supposed to do this. It's for debugging purposes, but I'm doing it anyways, and I kind of like it like this. Okay, so here we are. Cropout. Yeah, let me get my bearings. Let's see what's going on here. So first things first, it looks like we're in some sort of island. If I like fly away, we've got some effects. We have birds flying. This is actually an example of VFX. This is a particle system. So we got these bird guys in the air. It looks like they're really simple geometry. Whoa, that guy. Whoa. Some of them like they kind of stick around and then they. What is this guy gonna do? I feel like they speed up and then they like blip out of existence. Yeah, look at that. Wow, interesting. I wonder how that's working. And when I get close to them, no, they stay. Cool. We have waves. Oh, another particle system. So this is another example of VFX. And it looks like they're just these 2D textures that face us and they spawn on the surface of the water and they look pretty nice. That's kind of a cool aesthetic. Those little wave peaks. Wind swish. Oh, nice. What an aesthetic. Yeah, some ribbon particles that have like wind effects. Very cool. We've got background fog, which is just literally just a 2D grid with wow, that's so interesting. It's like
Wall Maria.
Underwater. Let me delete this. Yeah, so that's what it would have been without it. Wow. The light, okay, just a directional light. No, nothing surprising there. Exponential height fog. If we didn't have that, doesn't really make a big difference actually. We've got the sky atmosphere, which is what's generating the blue. If we delete that, it's black. And then the sky sphere, which is also contributing a lot to the background visual effect. Cool. Okay, what else? BP Island Gen. So this is the main blueprint that seems to spawn our island. Let's look at this. Let's see how this works. I'm guessing, okay, it looks like, hold on, BP Island Gen. The button over here says edit in C++, so dynamic mesh component. Ooh, is a mesh component similar to procedural mesh component, but bases the renderable geometry off of an internal instance. There's extensive support internally decomposing the mesh into chunks for more efficient render updates. So it looks like this is just some C++ shenanigans over here. If I click edit in C++, it's going to open up Visual Studio. I don't want to do that right now. I'm just going to trust that this simply generates the island. Like you said, it seems like it's a bunch of cones. If I move it around, my engine lags to death and then rebuilds navigation. Nice. We love that. Great, great stuff. Yeah, wow, that is so laggy. It does not like being moved. The player.
Yeah, it's because it has to like reconstruct the entire mesh from scratch every single time
Yeah.
and then reform it. It's a whole process.
Let's see it in wireframe. Yeah, there's the mesh, so you can see it's like triangulating stuff. That's pretty cool. So this is some procedural generation for spawning the island. And then
Are
we
they
have,
using nanite?
it doesn't not for the procedural mesh by the looks of it. Otherwise we'd be seeing the triangles. I think we would be seeing them change. We could check, right? So nanite, we could do visualize. Or actually under lit, this is
So
usually
they're
better.
in the nanite visualization.
Yeah, it looks like no nanite, but there is nanite on the foliage things, which are these the rocks and yeah, it looks like these are pretty high resolution. Like look in the top left corner, that's quite a few triangles for underwater stone that no one's gonna see, and nanite allows for that and handles it very well. We can see the triangles are like tessellating away as we get farther. Very cool. Very cool. Okay, let's go back to that. BP spawner. Okay, let's open up. So I click the little edit and blueprint button. Wow, okay, so we're getting some code here. First things first, get each. Okay, event begin play. Load soft class references. Asynchronously load classes. Target is BP spawner. So this is a function, I think. Yep, this is, okay, so this just calls this event. It's saying, this is saying, do this. This is a custom event. So in Unreal Engine, if you just do custom event, you can add custom event like so. So now we have a custom event, just like that. And you can name this whatever you want. And this is like, you can call this almost like it's a function. But, I mean, in many ways, it is fundamentally like identical to a function. If I hit compile, I can add input variables. So like maybe, you know, this custom event would be like kill player. And this is, let me make this a little bit wider here. This is a Boolean parameter. So this might be like ragdoll question mark. And then when we call this custom event, you know, on event begin play, kill player, it now comes up and we get to check if we want to ragdoll or not. Like you know, that's what that is. But the key here is that it allows for asynchronous calling. So he's going out of his way to call it asynchronously, which if I'd imagine that Unreal Engine uses like an event loop, maybe multi-threading. Have any of you guys worked with JavaScript?
Little bit, yeah.
Okay. Do you guys know what do you have any idea of like how asynchronous works? Do any of you guys know how asynchronous functions work in like any programming language by any chance? It's okay if you don't. I'm just
I'm not sure.
okay. Good stuff. That's cool. So, yeah. Let me break it down for you. I want to make sure that I don't lie to you, so I'm double checking the documentation because I personally do not know how asynchronous works inside of Unreal. So I'm just making sure that it's as I assume. Unreal Engine async event loop. Are events synchronous or asynchronous? Async tasks based on async events. Async. It's not clear to me exactly how Unreal Engine's asynchronous stuff works, but yeah, this is interesting. Async event Unreal Engine explained. I'm just trying to make sure that I got the documentation right. Unreal Engine has a useful feature called async task. Allows you to execute code asynchronously on a specified thread and is primarily used when the task is too heavy to be executed instantly without blocking the game thread. Okay, I guess I don't know if it just stacks them onto another thread, but let's say that it does. So the way that execution works with code, I'll do a little bit of MS Paint right here. We've got you have a node, right, and then another node, and then another node, and this one, finishes, and then this one moves on, and this one moves on. This is the same as like walking down a line of code, right? Hello world, hello print, whatever. You go down a bunch of code, right? Like if you ever write code in VS Code or something, there's a bunch of code. The computer is using a thread to run through this code. Your CPU is moving through this code. However, your CPU might want to execute some code asynchronously. For instance, there might be some code in here that's like say hello, like print hello or print hi, and then maybe wait for user input. Right? Wait for input. Waiting for input might take a while. The user might respond instantly, or the user might take an hour to respond. I might just sit there and not do anything and just stare at the window. But in the meantime, there might be some other code down here that I want to still be running. I want this thing to move past this and handle this somewhere else, because this might take a really long time. So async moves this to a different thread. It moves this task. This could be any task. This could be like render a giant image, render an 8K texture. Okay, that might take a couple of milliseconds that we don't want the whole game to freeze while that happens. So you say, do it asynchronously. Do it async. And then this moves on to a different thread. So there's a different line of execution handled by a different CPU, or it's different core. It could be on the same core with hyperthreading. There's a lot of ways that this might be working. It might even be on the same thread and waiting on an event loop structure, which is what JavaScript uses. I won't go into the details too much. But the point is, it is set aside and it is executed in a lazy manner at some later point in time, when it is convenient for your computer to do so. It might be, this thread might be moving down and it might hit some line of code that allows it to breathe for a second. It says oh, I'm not doing anything right now. So it jumps over, handles the async task that was queued up to be done, and then comes back. That's kind of how the JavaScript event loop works. But it's all over the place. So what this guy has done is he said, hey, do this thing, but do it in a separate line of execution when it is convenient. When it might be loaded onto another thread. I don't know exactly how Unreal Engine works behind the scenes, but that's what async means over here. Does that make sense? Does that make some sense? Maybe? Perhaps? Asynchronicity?
Yeah, that makes sense to me.
Okay.
Yeah.
Cool. All right, so let's see. Load soft class references. I don't know what this means, but clearly it's just calling this thing. So set this variable to be 0. This is a Boolean value to check if this process is done. Asynchronous load class asset. What is this? Async load class asset. I guess this is loads a soft class reference and returns class of the correct type if the load succeeds. So yeah, I by the looks of it, this is yeah, okay, spawn types. Let's see, spawn types, st spawn data. So this is saying load class 0. Get class 0 from this array of spawn types. What is an array of spawn types? Well, it looks like it's a variable that has absolutely nothing loaded in it by default. The Boolean is used as a blocker to stop spawning until all classes are loaded. This is needed for lower end platforms like mobile. So this is almost like a loop. It increments the next class to load. If it is more than the last index, return that we've completed. Otherwise, call itself. So this thing just keeps calling itself, and it loads all of the classes from this array. So this is an array, and spawn types is the type, right? So you could have an array of strings, an array of integers, an array of booleans, an array of floating point values, an array of classes. This is an array of st spawn data. What is st spawn data? It is a custom data type. And if we look it up, we can learn more about it. So spawn st spawn data. Okay, it's not really clear to me what. Select the variable's current type, st spawn data type. Let me do a thing here. I will there's a little gear here. I'm gonna do show engine content. I'm gonna do st spawn. Interesting. I can't seem to find what this data type is exactly, but maybe we can learn more by trying to add a value. So it takes a class reference, it takes the biome scale, the biome count, how spawn per biome. If I hover over this, it doesn't look like it has any details about it. Random rotation range, scale range. So this looks like a way to spawn random structures. That's what it looks like to me, but wasn't completely sure. And it loads a bunch of soft references. Interesting. Okay, I guess this loads them into memory or something. That's cool. All right, what else happens? Spawn mesh only. Auto spawn. This is just some flow control over here. Retriggerable timer that waits for the navigation system to be built and soft classes to be loaded. This is needed because the assets we spawn will cause the nav mesh to be rebuilt. Rebuilding the nav mesh will help reduce overlapping assets. Gotcha. So I guess they spawn a house, and then after spawning the house, they don't spawn the next one until the navigation mesh regenerates so that they can avoid accidentally spawning a house on top of another house. They decide where to spawn like things based on the navigation mesh. I guess they probably pick a random location on the mesh. I'm guessing that's how this works, just based on this explanation up here. Is it ready to spawn? Yes. Nav check handle, pause, timer. Get the navigation system. Is it being built? No. Otherwise, spawn assets. Spawn assets, which calls this function. Okay, so what I've just done is I've gone into a function, right? There's multiple functions over here. Spawn assets takes in spawn parameters, how many biomes, the scale of the biomes, and it takes in a class, and it gets a random location on the nav mesh. That's exactly what we thought. And based on the location on the nav mesh, it spawns objects, spawns an actor at that location based on some of these other properties. Nice. Okay, pretty simple. So this function just spawns objects on the navigation mesh. And if we go back to the main event graph, we can see that this whole process here is, spawn the class, update the variables that are controlling the flow here to make sure navigation gets regenerated. And then once, I guess we do spawn instances. Once finished spawning blueprints, spawn the instant static mesh array. Ooh, so this spawns blueprints, but this spawns instant static meshes. So they handle that separately. I have a feeling that that's interesting. So this is like, are we done spawning blueprints, which are like, interactable buildings and whatever else this game works with? Yes. Then spawn static meshes. I don't know what kind of static meshes they would be spawning. There's no array in here to explain exactly what they're spawning, but they are spawning, presumably, some sort of static meshes. Okay, all right, this adds up. Everything makes sense. And then once that's done, they call finished spawning. So this is when the whole procedural generation step ends, and they call these events. They get the game instance, and on the game instance, they call this event dispatcher. This is like sending out a message on a loudspeaker for anyone that's listening. And it's saying, hey, update all interactables. I don't know what that means necessarily, but we'll see. And they also call spawning complete after that finishes. Awesome. Okay. Okay, great, beautiful. So we understand now the steps that they're taking for the procedural generation. That's interesting. Like I don't fully understand it, right? That was a quick run through, but we have a vague idea that this BP underscore spawner, it loads all the buildings into memory, it spawns all the buildings, and it spawns a bunch of static meshes, and then it calls this event dispatch. We haven't actually gone into event dispatchers, but that's all right. Instanced foliage actor. This is just the foliage, so we don't need to really think about that too hard. This is the navigation mesh boundary. Okay, that's honestly a really big navigation mesh for an island that only takes up this much space. I mean, this literally goes outside the bounds of our like interactive gameplay world. So unless you can build more island, this is really wasteful because this is like computationally expensive. It's probably like exploring way too big of an area, but that's okay. And then recast navigation mesh. This is just parts of the nav mesh. That's the water. That's the underwater. Okay, great. Let's hit play, and we should expect. Also, we have the player over here, right? So this is the player here. This red line, you guys might recognize it from one of the earlier tutorials. This is like the spring arm, the camera spring arm. And it looks like the player probably uses WASD to move this thing around and rotates with their mouse. I'm guessing that's how this is going to work. Let's hit play, see what happens. Oh, whoa. Oh, look at that. Okay, all right. Yeah, you guys saw that. So wow, yeah. We saw the steps in action. We saw the building spawn first, and then the trees spawned. Awesome. Okay, so that, we understand what happened there. There was a bit of lag, right? Let's run that again. We should see like some buildings first, and then the foliage. Awesome. Makes perfect sense. Good stuff. And so we're using WASD to move around. I'm using scroll wheel to zoom in and out, and it looks like at different scroll levels it also rotates the camera down so that we get a more horizontal perspective. They have depth of field enabled, which gives a really aesthetic effect when we zoom in too far. It's like blurry. As you zoom out, it gets better. Oh, -9 pumpkins. We died. Oh my god. That's great. Oh, there it is. Spawned them again. First
Yeah,
the
you
blueprints.
survive for like a minute and then you die.
Dude, yeah, I don't know. 100 pumpkins. If I hit space, it gives me a build menu. Wow. Okay, I don't know what I'm doing, but we'll work with that in a minute. So we have the player and the spawner and the island generation. The spawner is handling the placement of buildings. The player, let's take a look at the player. Let's actually see what the player is up to. So edit the blueprint player. Oh, island gen is a blueprint. Oh, look at this. Here's island generation. Okay. Get the dynamic mesh. Reset the component, and then append a bunch of cylinders together, add a box to the base to join them, solidify the mesh, tessellate, calculate. All right, whatever. So this is procedural mesh generation done entirely in blueprints. No C++ at all. That's great. That's spectacular. So great. It really shows the power of blueprints. I'm glad to see that. Very good. I don't see much else going on in here, so I'm not gonna worry about that. You can just take my word for it, right? I mean, let's look at the player. What is the player doing? So, okay, we've got a few components here. We have the default scene root, which is just a root component. I'm not sure how that's working exactly. We have the spring arm, which we understand how that works. It's just a probe. It kind of tries to position the camera at the end of this red laser. If the laser hits anything, it moves the camera in. It also has a bunch of functionality for making the camera move gradually. The camera itself, which has post-processing effects. So all of the post-process stuff I talked about yesterday, you can also manipulate it at the camera level, not just at the post-process volume level. Presumably this thing is going to have some depth of field effects in here, which we were seeing. Yep, there it is. Focal distance, depth blur radius. So this stuff is what's giving us that blurring effect, presumably. Cursor. Cursor. So the cursor is just a static mesh of a ring. Great, that makes sense. Yep, just a very simple mesh. Collision. I guess that's to check if we're hovering over something, right? So you can use collision not just to like actually enact physical collision or prevent things from walking into you. You can use collision as like something has to have collision for it to check if something else is inside of it. So this right here under collision presets, if I click this drop down, we see there's no physics collision and it is set to overlap everything. So that means everything can pass through it, and this query only versus physics only versus query and physics, what this means is it is only able to check if other things are colliding with it. Other things do not check if it is colliding with them, if that makes sense. It's like, what direction does the collision go in? This object can check if other things are inside of it. Other objects cannot really... Like if I had it as physics only, this object would not care about other objects, but other objects would care about it. I don't... the explanation here is better. Like, only used for physical simulation versus only used for querying, like raycasts, sweeps, and overlaps. Yeah, I did not explain that very well. Sorry. Just, don't listen to me. Listen to the official documentation. There's like a paragraph for everything that you hover over in Unreal Engine, which I think is probably one of its most powerful features. Okay, so how does this work? We got a movement section. So wow, there's two different graphs. I've actually never seen that before. They organize the code into two different graphs. We have a movement graph and an event graph. In the movement graph, we have enhanced input action move. So this is the input system. This is capturing WASD, but it could probably be easily rebound to anything you wanted it to. And it is doing add movement input to the pawn. Interesting. So add movement input sounds really vague, and it is kind of vague. The reason that it's so vague is this pawn is using this class right here called floating pawn movement, which is either a plugin or a C++ class. Floating pawn movement is a movement component that provides simple movement for any pawn class. Limits on speed and acceleration are provided while gravity is not implemented. Normally, the root component of the owning actor is moved, however, another component may be selected. So for those of you that come from Unity, this sort of makes sense. This is like having a script attached to your object. This script, this class, this component, when it is inherited, it grants abilities to the actor. It exposes an API, and the API it exposes is this add movement input, and presumably it has all sorts of properties, right? So if we look at the details when I click on this component, we can see under movement capabilities, we can see aspects of navigation, we can see velocity, acceleration, and presumably, perhaps the most valuable resource of this is that it includes multiplayer functionality. Like, I bet this is built into the engine. I'm not sure if like a raw instance of Unreal Engine comes with this, but I'm guessing it does. And if it does, this presumably has a lot of multiplayer features. They're not being used in this project, but making player movement synchronize with a server in a super accurate way is a tall task. And it gets more complicated for competitive games like CSGO and stuff. Doing movement prediction, it's all a very interesting and complex thing. And Unreal Engine's character movement components, any component that's related to pawn or character movement, tends to ship with these multiplayer features enabled. So that's just a little fun fact. But sorry, bit of a detour. Drag move. Interesting. So this is wow, just some fancy action. Get player controller. Wow, okay, and then enhanced input local subsystem. What is this? If I double click this, whoa, okay, Visual Studio is opening up. Oh god. Oh boy. So this is a custom node by the looks of it. Remove mapping context, track move. Wow, I'm not exactly sure what this is, and I don't know why they chose to implement it in C++, but it's opening up on my other screen. All right, here it is. And it looks like it's quite a bit. Let's see. Get user settings, protected, enhanced input API. There's nothing interesting happening here. I'm not even gonna, I don't know what's going on in there, and I'm not gonna bother with it. I think that this isn't even being used, if I'm being honest. Oh, looks like I accidentally moved this node over. Enhanced input action, zoom direction, update zoom. Okay, so this is zoom. Oh, depth of field. DOF typically stands for depth of field. Let's see what this does. So as we get closer, it adjusts the focal distance to make things blurry. That makes sense. Okay. What else we got here? So that was movement. This is all just really simple movement for spinning the camera around, and drag move, which I guess like picks up our mouse. But this looks like this looks like it's really complicated, so that this thing works on mobile devices. Like this game is supposed to demonstrate that it can work on consoles, mobile devices, everything else. I don't think we're using this. Like if I deleted this right now, I'm sure it wouldn't disable any part of the gameplay. So that was movement. Under the event graph, we've got all sorts of things here. On begin play, start boundary check. Interesting. So, whoa, okay, add mapping context. Villager mode. Base input. I don't quite know what's going on over here, but I suspect this mapping context stuff has to do with the input system, and it's just talking about like where our mouse is, and if our mouse is on the screen, like start tracking it. Yeah, this is more mapping context shenanigans. I'm not going to bother with that. When hovering over an actor, check if the actor is the closest available actor in player collision. That makes sense. So if we're hovering over an enemy or one of the villagers that are walking around, it wants us to make sure we're clicking on him. And the way it does this is when actor begin overlap. So I guess this is when our circle starts to overlap somebody. Treat that as the hovering actor, and then get all overlapping actors. And if the actor, okay. I'm not gonna. Honestly, I feel like I'm going into too much detail. I feel like I don't want to waste too much time here. Is there a particular system in this game that seems like exceptionally interesting to you guys? The building system, perhaps, or the villager AI is probably a big one. I've just been rambling. You guys there? Oh, there we go. Here's the drag move. There we go. I can drag with my mouse. I was using WASD earlier. So this is the enhanced input system. I feel like you could have done this using Blueprint without the enhanced input system, but I guess they wanted it to work on mobile devices, and they don't have the best support for mobile, so it wasn't part of the API without a bit of C++. Here's the overlap. So on actor begin overlap. This is like, oh, we have begun overlapping. Let's set this to the hovered actor. Hovered actor. Hovered actor. Hovered actor. Yeah. There we go. Oh! I clicked on him and he disappeared. Come back. Can I shift click them? Control click? Whoa! Okay. I can click on this guy, and I can control drag and send him places. Oh, look at that. It's like pathfinding. Ooh. Go over there. You.
Now, is that the nav mesh doing that pathfinding?
Absolutely. The nav mesh is necessary for the pathfinding.
Gotcha.
Can I double click this thing? I have no idea what this thing even is. I'm gonna pause the game. Oh, it does not let us move around. Let's turn down the music. Turn the sound effects a little bit down. And let's build something. Why not? I can't afford anything. Classy. Oh, and I hit escape. God, I tried to hit escape to exit the build menu. It looks like my villagers are gathering things. The birds are very...
Chop some trees.
Yeah, we gotta chop some trees. I guess this guy's going at this bush. Oh, look at them. They have like little apples. Oh, that's so cute. Dude, this is such an aesthetic. Like, really nice art. Probably very optimized as well. Okay, we got wood. Okay, alright. What, cornfield? What are we thinking? Lettuce field. Let's see how the building system works. Ooh, I have to drag it around. Is it grid-based? It is grid-based. Okay, there's a grid. There's definitely a grid. It looks like the grid is like we're taking up 2x2. Let's do rotate. Okay, place. Ooh, and the landscape automatically. So this coloring effect on the terrain, very interesting. I believe the way this works is runtime virtual textures. I will confirm that later, but runtime virtual texturing is a terrain. It's very useful for terrains, and it lets you not only like paint the terrain in real time, but also sample the terrain color. So notice right here, the edges of this field mesh are blending really smoothly with the ground. That might be careful forethought on their part, where they gave it a texture that had that blending, but it might also be... Well, did I just cut down our...
Whatever you get,
It's still there. It's not rendered.
Yeah. Wow, okay. A monument, the Unreal Engine logo, that's crazy. Pumpkin field. It's all click and drag. Interesting. Let me place this over there. Can we get more villagers? Whoa, I was able to drag off of it. Oh, okay. Sure, we'll place like 20 of these guys. Why not? Bang. Yeah, that's really interesting. It's like... Huh. Place that over there. Oh, let me... Okay. A tree? We can plant trees? Good stuff. I like some trees. Oh, and the trees are being placed instantly. I guess I get to be God. This is costing me? It is costing me. It cost me some wood. Okay. Whatever. We're definitely doing well on food. I don't see any pumpkins or anything growing yet. Oh, and I hit escape. I'm such a dumbass. Oh, I hit escape. Whatever. Okay, we got some idea of some more functionality. The building is grid-based. That's kind of interesting. So I'm guessing that the grid-based building system is in here, right? Event begin build. Presumably this is when you click spawn a class. Is the class spawned? Yes. Destroy actor. Spawn. Oh, spawn, I'm guessing, is the, like, virtual representation of the class. Like, when the green glowing, like, cornfield is waiting to be placed, it destroys that, spawns the actual class, and then placement mode. Ooh, enable ground blend. Ooh. Set the tags, placement mode of the static mesh. Interesting. I'm not really 100% sure what that is, but like, okay, tags are just wobble, set vector parameter material, wobble vector. What is this? Get actor location, normalize. It's so interesting. Remove if exactly overlapping with another interactable. Oh, okay, so this is PCG is procedural content generation. So they're suggesting here that the whole system for placing objects should be handled by the procedural content generation system, I guess. BP Interactable is a base class for interactable stationary actors in the world. It acts as a container for basic information that all interactable items will have, like their display name, spacing override for the navigation mesh, and meshes to use. There's also a box collider. The sizing is set in the construction script. So the construction script picks the mesh. identifies the boundaries of the mesh, and per the bounds of the mesh, describes the bounding box. Interesting. Okay, well, I don't. That's cool. It's pretty cool. Let's look at Villager. Let's look at the Villager AI. That's probably one of the more interesting features here. And then after that, we'll look at the particle system, and I'll call it a day. I think looking at the villagers is a really good idea. Here's let's look through the content. So we've got the main menu map. Let's open that up for a second. Here's the main menu. Okay, so when we hit play here, beautiful. That's so cute. That's so cute. It's like nice music playing too. Wow. Okay. And then this is the village map, which we were just on. Here we go. Nice. Visual effects. Okay, so here's the different particle systems, like the birds and the waves and the wind sprites. Very cool. The UI elements. I won't bother with those for a second. Splash screen, not really relevant. Pack ignore. Pack ignore. Interesting. Not sure what that is. I won't click on it for now. Elements of the environment. Okay, here we go. So you can look at some of the interesting graphics. Here's a bridge. I feel like there's more to this game than we realize. There might be like a way to build out into the water. Very cool. So
I'm trying to build that monument.
Yeah, this is a very nice static mesh, very solidly done. We can look at some details like the actual mesh density. You can see it's a surprisingly dense mesh, but I imagine that they're using nanites, so they don't feel a need to optimize it dramatically. They kind of preserve some of the interesting curvature and lumpiness on the edges. And even though this is a mobile game, you can run nanite on mobile phones, so that's pretty cool. Nice. Materials. Here's the water material. I bet this is pretty complicated. Nope, not complicated at all. Very simple. It looks like they... Excuse me. They have some sort of wave texture, and they move that texture around. Nice. Very simple. I don't even see this thing displacing. Can I make it real time? There we go. Now it's like going up and down. There she goes. Very cool. Gentle wave effect. Textures. Ooh. The villager textures, the pickaxe textures. Very cool. Meshes. Here we go. Here's some villager stuff. Okay, so let's take a look at the villager. Wow. Oh, what a cutie. Okay.
Damn,
so,
that nose.
Yeah, he's got a snout on him. So we see he has a root bone. The root bone is between his legs. Cool. Connects to the pelvis. He's got his spine, clavicle, whatever, all the bones are properly rigged. His hand has an independent yeah, the hand bone versus the thumb. Okay. Clavicle. It looks like he has leaf nodes, which is kind of surprising. Head socket. So this head socket is probably what different hats are attached to. So sockets are there to like be positioned such that you can place other objects and attach them to them. That was the skeleton. This is the actual skeletal mesh. So in this editor, see, there's a few different up here. This browser lets you like look at the different layers of data that go into a skeletal mesh and treat them separately. This is the... What is this? This is the... That was the skeleton. This is the skeletal mesh. So this one is the skin that we're currently looking at. I mean, we could see it on the last one, but it was more of a visualization. This editor is here to tell us about the skin. So we can see the materials that are applied. It looks like he has 2 material slots, one for his body and one for his hat, which is, I guess, by default in his hand like this, I guess. But if, I don't even, I'm not sure how that's working, but that's cool. And we go over here, now we can see all the different animations that were imported with this skeletal mesh. We've got building things, carrying things, cool, farming, nice. Okay, I see. The hat is okay. I see. So this would be like a shovel, but the hat object like is just whatever he happens to be carrying. Sometimes they wear it as a hat. Sometimes it's like a bucket where they fill it with apples and it goes on their head. Other times it's like a pickaxe and they just swap it out. That makes sense. Walking, wood chopping, nice. You guys are maybe wondering some things. This right here is an animation notify. So what this is this calls an event. You can access what event this calls. Here, it's playing a sound. So it's saying the moment that we get to frame 15, play this sound file. Which is actually, I'm pretty sure this is dynamically generated. Yeah, they randomly change. Wow, yeah, I think they're procedurally generating the wood chopping sounds. That is hilarious. That is hilarious. They are procedurally generating the wood chopping. Nice. This sound is completely random. That's cool. This right here is an animation montage. So these were animations. An animation montage is a combination of a few different animations. So we are doing, see this building animation? That's being done here. But it has some other properties to it. We have an impact effect, which plays a particle system at the point of impact. That particle system right there. Smack, 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 smack. And this right here seems to be, let's see, what is this? There's a timing thing here. I don't know what that is, but that's pretty cool. I mean, yeah, all I really follow here is this particle system. I don't really know what else exactly is going on. It's like a mining. Mining is doing the same, putting things down. They just use the same impact particle system. Very cool. Chopping wood and working. So yeah, these animation montages combine together multiple assets. And then if we finally go to this is the animation blueprint. So animation blueprints help do more complex animation features like a state machine or something that transitions between different animations smoothly. I don't think these guys do that. Yeah, it looks like they just, yeah, they don't really have anything complicated going on in here. Copy pose from mesh. Copies the pose data from another component. Yeah, there's not, I don't think there's much going on here. I know this says hair. I don't think it's H air. I don't know what this is. But it doesn't look like it's doing almost anything. Cool. So we've explored the villager mesh. Here's the materials. These are the same animation assets that we were looking at. What is H air? That's an animation blueprint. What is H air animation blueprint villager? Okay, here's some more shenanigans. Yeah, there we go. Here's the animation graph. So this is the animation graph, and what it's doing is it's taking the pose from a state machine, it's outputting it to this is like an output, this animation slot, and it's also outputting the pose in accordance with the slot. This is like caching the animation. That's what that I think does. And this is the state machine. So the state starts in idle and transitions from idle to walk. And these transitions are, the transition is based on his velocity. So if his velocity exceeds a certain speed, he can transition to the walking state. And in the walking state, he is either playing the carry sequence or the walking sequence, depending on whether he is carrying something. Otherwise, if he, here's the transition back, if he is going slower, if the length of the vector is less than or equal to 0, so he's not moving, then he can enter the transition from going from walking to the idle state. And in the idle state, he just plays the idle sequence. Very good. So this is the animation blueprint. and it drives the animations. Finally, the villager blueprint. So we're working our way from the bottom up. We looked at the skeleton, we looked at the materials applied to the skeleton, we looked at how animation assets come together with different events, and the animations form animation montages. Animation montages are executed in the animation blueprint. A state machine derives the transitions between like the walking state or the carrying animation, the walking or the idle animation, and in the walking animation it decides if he's carrying something or not, and accordingly plays the animation by checking a variable on the blueprint. Here is the villager blueprint itself. This is probably going to be one of the most complicated or interesting blueprints here. Let's see. So we've got a villager. Villagers using floating pawn movement. That's pretty cool. So this is like two-dimensional kind of hovering pawn, no gravity, just walks around. Decal. Decal is presumably his shadow. I'm guessing that's what that is. We can test this by just dragging him in here. Let's see. What? So decals are a way to project an effect. Oh, yep. See this like black shadow that, or is that actually it? Hold on. Let's see. What is this decal? Yep, it is a shadow. So the decal is projecting this shadow effect onto the ground. That's pretty cool. Radial gradient. It just projects a shadow material onto the pixels beneath it, overlaying with the material beneath. We have hair. This is not hair. It's H-air. I don't know what that stands for, but it's a skeleton. This is the tool. So the tool is bound to the parent socket. So look at this. We could have put it on the head socket, and now he'll probably carry. Now that we've made that change, the villagers are all going to carry their like pickaxes and stuff on their head. But if I put it on the hand socket, it's going to be on his hand. And then the hat, which looks like it's a separate skeletal mesh, and the actual villager body, which, yeah, cool. Oh, no, that's the villager body. This is H-air. I just don't know what this is, man. I just do not know what that is. There's not even the skeletal mesh asset tied to it. I don't know what this H-air thing is, but probably doesn't matter too much. Let's close all of these tabs and start picking this thing apart. So, event graph. All right, let's click on the event graph. Okay, here's the villager. Offset the capsule. When we start a timer for when we need to eat. Okay, so I guess they pause and they eat every 24 seconds. Set,
so that's why you died within like a minute.
Yeah, they eat every 24 seconds. Yeah, I guess.
Okay.
And then set current tag as job. So new job idle. Okay, so change job. Change job. If I double click this, change job is a function. And how is it implemented? Interfaces. Change job. There's a change job interface. Presumably this calls. Okay, I see. They track what job we're using. So here, let's see. Like, here's the different variables that the class is storing. It has a variable called job, and job is it's a string. It's pretty much a string. Yup. And they set it to idle. And change job. Can I find references? Here we go. Event change job. There we go. So this right here calls this event change job, which is implemented in an interface. So what this interface is doing, interfaces, guys, they're a generic programming concept. This isn't just like an Unreal thing. Most of this is not just Unreal things. Everything that you see here is like pretty standard run-of-the-mill programming. Change job is part of an interface. So an interface is like a collection of functions, but the convenient part about them is that you can access them from outside in a consistent way. So you can be like, yep, I trust that all villagers implement the interface, villager interface or something. So if you have different classes, maybe you have like a fat villager or a tall villager or an angry villager. I don't know, whatever like different like aesthetics you give them. And if in some way they're functionally different, but they all implement the villager interface, then you can trust that they all have the change job function. So you can call the change job function on each of them and expect that it will be implemented on them in some way. So here, change job is implemented accordingly. We set the job variable, and then we get a row from a data table in accordance with the row name for jobs. So there's a giant data table called dt underscore jobs, probably under core. It's probably in here somewhere. dt under content somewhere. There it is, dt underscore jobs. So this data table is like a spreadsheet, and they find the row that matches the right name. So we find the idle row, and it picks the right animation, the right hat, and the right tool. Nice. And it has a behavior tree associated with it. So this behavior tree is a sequence of decisions that the AI can make. So the AI starts up here, and this selector runs. Let's double click the selector. Oh, never mind. Nothing happens in here. What is this? Selector. Selector executes stuff from left to right. Okay, whatever. So this is like do the below in sequence. So selector clicks this guy, and this guy does this. Run EQS query. EQS is the environmental query system. So what this is saying is generate a grid of points in a square around me and check all the points. So run EQS query. I wish I could actually inspect this. Result Blackboard key. Run EQS query EQ underscore town hall. So there's a query called EQ underscore town hall. EQ underscore town hall. EQ underscore town hall generates a grid of points 2 meters apart and generates them in a circle around the town hall and attempts to identify if we can reach it via navigation, I think. Cool. Very cool. All right. So the villager, right? Here we are in the villager. Get data table jobs. And then reset the job state. And then it looks like he does run behavior tree. So run behavior tree runs the behavior tree that we found from the spreadsheet. The spreadsheet goes here. We're in idle mode. We go to the town hall. If we can reach the town hall, go to the town hall. Once we finish going to the town hall, so once we're within 5 meters, I guess, of the town hall, play the sleepy effect. So there's a particle system. This is a particle system for being sleepy. Cool. We saw the little Z's there. Zzz, he sleeps. And then back. And then wait 4 seconds, 4 to 8 seconds. And I guess while that wait happens, if the original sequence fails, reset the AI to a new position around the town center. So again, run the EQS query, see if we can spawn in some spot around the town hall, and run this stuck recover thing. And stuck recover is just a task, and it says, when we receive the execute call, set the actor location to the recovery position, which is a value that is stored on the actor's blackboard. Blackboard is like think of a football coach that's drawing X's and O's on a whiteboard and making up a game plan. It's the AI like planning things. So there's a asset called Blackboard, and it's where you're supposed to organize variables related to AI decision making. This is Blackboard down here. Blackboard is attached to the behavior tree. So there's a behavior tree, and there's this Blackboard right here, which organizes some of these different tasks that an AI can take on. So this is how AI is implemented in Unreal Engine, with behavior trees and their corresponding variables that they reference, and decision making is done like this. We could add other tasks here. We could say like run behavior, and what behavior should we run? The behavior asset BT underscore build, and this will call another behavior tree. So when they're idling, now, since it runs things from left to right, if the reset thing fails, it'll try to run the tree here. And it'll enter the tree, and it'll go from left to right, and it'll say, find the nearest of class. So find the nearest interactable, find the bounds of the interactable, identify if we can access the interactable, move to a point around the interactable. So this like spawns a bunch of random points around a bush, identifies if we can access them. If we can, go to those points, rotate to face the bush, and then begin, I don't know, picking apples from the bush. And if we can't find anything, return to the idle state. I hope you guys get how this works. So I've absolutely speedrun like the AI process. But yeah, okay, so there we go. Has this been like insightful, guys? Do you feel like this is it's a good idea of how this is all coming together?
This certainly gives me a lot of stuff to build on.
Yeah. Behavior trees they look complicated, but they're really simple. They're really simple. Look, there's a really finite amount of nodes here. Selector, sequence, parallel execution. And then off of a selector, you can run all of these tasks that were already like created, or we can do these things like move an actor to a location, run behavior, run EQS query. And EQS queries are what? They are the environmental query system, which, I mean, like let's look at this guy. Yeah, like the EQS queries are very interesting. You know, place points on a grid, and then based on these points, you know, do other things. Like it's a way of just examining the environment. Say you had an FPS game and you had some enemy AI. The enemy AI could use EQS for a cover system. So they might check a grid around them, right? Let me explain how EQS works. Say we've got a FPS game, and the FPS game looks like this, and you are over here, and the enemy AI is over here. Enemy AI might, in its behavior, be like, oh, I am being seen, I need to take cover. So it runs EQS, and EQS samples. It goes point, you know, it does a bunch of points in a grid around our AI, and it checks for each of these points. Can I be seen? 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 And all of these fail, and it's like, oh, this point is behind cover. So it selects this point, and then the environmental query system returns, go to this point. That's how EQS works. That's the idea behind EQS. Here, it looks like all they're doing is generate around EQC collection targets. So, actors of class, yeah, generate set of actors around querier. Yeah, this right here is, yeah, query parameters, yeah, whatever. So this right click to add tests, add test. So you can, yeah, we can generate like points, and we can pick a point such that you know, trace visibility. So we can say it must hit, you know, XYZ. Yeah, this would be like the trace that I just showed on MS Paint. We could check, you know, require a hit or something. Yeah, I don't know, scoring factors. So I guess we can reward the score based on something, and it'll pick the best option. Anyways, okay, this has been quite a deep dive, but we have a good idea of like how this whole system is coming together. I mean, we explored this really thoroughly. There's a job system for the AI, and they pick their job. You know, they decide, okay, let's eat. Otherwise, they just idle between jobs unless you give them a job, by the looks of it. So, pretty cool. Pretty cool. Pretty simple. Not too complicated. This is honestly like a pretty game jam doable game, but they're doing best practices here. That's why it kind of seems a little bit complicated. They have like extra stuff there to make sure that everything works. in multiple scenarios. But for a game jam, you can have some bugs and miss a few edge cases. The only thing I didn't really cover was particle systems, which I know Ashley was interested in. I'm going to, I guess I'll take a quick second. I'll take a real quick second and just click VFX, and we can look at something like the flying bird. Here's the bird particle system. They're a little bit difficult to see. I wish we could give them an outline, but I can see them. And it looks like the way that they're doing it is with this right here. So the way Niagara works is particles are organized into these like stacks. So this is like a single particle system, and you kind of set different qualities from top to bottom. So the first thing that happens is we describe the basic properties of the particle. We say it's going to be simulated on the CPU, not on the GPU, and it's dynamically recalculating the bounds of the particle system. We add how are those particles are going to spawn, but it looks like we don't worry about that. Instead, we spawn them. Instead, we do emitter update. So the life cycle, the spawn rate. So this is how the particles spawn. We say spawn the particles at a rate of a multiplier of 1. Spawn particles with a lifetime between 15 and 20 seconds. Make them be 2 to 3.5 times their normal size. Scale them 1 to 4 times if they're a sprite versus if they're a mesh, I guess. Where should they be placed initially? They should be placed in a box 9,000 by 9,000 by 2,000 centimeters, so 90 by 90 by 20 meters. And also reposition them inside of a location, I guess, a random sphere of radius 1.25 meters. Not exactly sure. And then it looks like here they make sure that particles are killed when their life ends. They scale them over time, so the particles spawn with a scale of 0, and the bird like appears really quickly. It scales up, and then it stays a constant size over its life, and then at the end of its life, it scales down. And they move around using curl noise. Curl noise is a vector field that you can use. Curl noise is one of the more beautiful effects in games. Whenever you see particles doing that like wispy effect anywhere,
would rotate.
It's curl noise. Let's see a final effect here. Come on. Can we? Okay, this Houdini was not the best example. Curl noise, interactive WebGL. Let's play with it in Chrome, please. 3D curl noise. Here we go. Come on, show me some. There we go. Curl noise. Curl noise. This is curl noise. It's a vector field that is computed from. I think they work backwards from they fill a bunch of points with levels of curl, and they integrate back to the OG vector field. They integrate the curl, so you end up with the gradient field that just describes the velocity of the particles. I think that's how this works. Not 100% sure, but yeah, curl, very cool. This like super cool turbulence effect that you see in games is not an actual fluid simulation. It is a vector field generated entirely from noise, so it's pretty performant. So they're using curl noise to move the birds around. They give them some drag values, so I guess they never accelerate beyond a certain point. They also give them a vortex force, which I suppose makes them kind of spin in circles over the island. And they solve all of the forces together and render meshes for every particle. So that's what this is. It's like a stack of instructions that sort of execute sequentially. Set the properties of the particle, describe how it updates, describe where it's going to spawn, how it's going to change over its life, and then what it looks like at the end. I don't entirely understand why they visualize it like this, but yeah, this is kind of how particle systems have always been traditionally visualized in game engines. I mean, even like a long time ago. And it's pretty flexible. You have a lot of powerful things that you can do there. So that's a vague introduction to visual effects. I'm sure the wave tops are like significantly simpler. I mean, it's doing nothing but spawning these on a flat plane. So pretty simple. Yep. And I think what they're doing here is they're exposing certain parameters. I think that's what we're seeing here. But yeah, it is now 6:10. God, whew, 2 hours. Whew. All right, I'm gonna end the recording because I was recording this, but what a speed run!
Mhm.
Oh man.
Yeah, dude, still riding that 2 hours of energy.
Yeah,
Really stretching it.
yeah. We sort of explored everything that there is to explore about this project. I'm not gonna lie. Like we saw a taste of the AI, the environmental query system, Blackboard. We saw procedural generation being done to spawn buildings and trees, procedural generation on the island mesh itself. There's a lot of really cool functionality in this project, and it shows you like I mean that felt like a lot, but look how few the nodes were. You know, like it was only a relatively finite, small set of instructions required to build a very interesting game. We didn't talk about the UI much, admittedly. The UI is probably a significant part of this, like getting the nice buttons at the bottom and making sure that when you click on a button, it picks the appropriate class to build. And we also didn't talk about gameplay framework. That's the one other thing. So gameplay framework is those high-level classes that hover above the game and oversee the functionality. If we go under
Yeah, I guess
game
we're gonna
mode,
turn the recording back on.
I'm still recording. We got the heads-up display, the player controller, game state, base, player state. So these player state classes, if I do find, this is going to take the editor. So clicking this button usually sends you to the class, but this game state base class, they haven't even touched it. So they don't have a custom game state. They don't have a custom player state. They don't have a custom spectator pawn. The only thing that they change is the player and the player controller class. The player controller class is dead simple. All it is it's kind of it looks like it's just processing some of the input depending on if it's coming from a mouse or a key press, whatever.
What happened?
Just a tiny layer of input processing is adjusting this enumerator. I don't know. I guess to prevent conflicting controls. So if you like drag with your mouse to the right, but at the same time you're swiping to the left on your phone, and your phone is somehow connected to a mouse or something, it won't interfere. I guess I think that's what's going on here. It's like gamepad versus mouse versus touch.
Common issue.
Yeah, very uncommon. Yeah. I mean, that's really so. There's like next to no gameplay framework stuff. That's pretty hype. And certainly no multiplayer functionality. But everything else in here is pretty nice, pretty good, very good. I'm glad we were able to pick that apart in such a short amount of time. Wow. Yeah. Blueprint function library. So this is like a convenient library of helper functions that they expose for everyone. What is this? An interface for the player. Begin build, switch build mode, add UI. I don't know why you would even use an interface there, because you can sort of trust that there's there isn't multiple players. This isn't a 2-player game. At least I don't think there is. It'd be really funny if there's some multiplayer functionality just sitting under our nose. Don't even see it. But I doubt that.
I don't even know how.
Yeah,
Like, what multiplayer?
Yeah, they would have to have like a separate server state and some sort of code that, like, we would have seen something. We would have seen like a node that has a little icon on the top right that says that it's like calling a event on the server. But we didn't see anything like that. Oh man. Oh god. Okay. Now I'm gonna go to the gym. Guys,
Awesome.
you should explore this for yourself. See if you can kind of sit and stare and look up what different things do. But it is a bit of a more complicated example. I no longer recommend the ARPG. I feel kind of bad. This content examples project that I told Ashley about is so healthy. It is so simple, And it is intentionally designed to just be super accessible. Like it's nothing. It's meant to be navigated in the editor. It's not a whole game. It is just tiny functional pieces being very, very carefully explained. It's one of the simplest and yet most like. I mean, it's designed to teach you how to use Unreal Engine by just walking through it. So content examples. It's under sample projects. It's well maintained, and it breaks down all the different like parts of Unreal so well. It shows you like everything that you could possibly do with particle systems. It shows you how to do multiplayer. It shows you like every system at a surface level. It honestly better than the documentation in some ways for learning things. Like, look, here it is. And all you do is you just go to maps and you pick what you want to learn about. Do you want to learn about audio? Do you want to learn about the machine learning animation deformer? Do you want to learn about landscapes or perhaps navigation meshes? Or maybe you want to learn about materials or volumes or fluid simulations. Let's look at the fluid simulations. They're always really pretty. So you just double click it, it loads the map, and then you can, either fly around in the editor or just walk around in the game. It does give you like the ability to walk around like it's a big museum. And it's so cool. It's like aesthetic and interactive and interesting.
Yeah, it's amazing.
Yeah, it's really good. Here we go. Here. Wow. Time to see some fluid simulations. Examples of 2D and 3D gas and liquid simulations. Shows how to set up collision objects, lighting, simulations, quality. All the simulation logic is defined in Niagara and is not hidden in engine code. You must run in play and editor to see the simulations. Oh, my GPU took a hit there. I don't know if you guys saw that stutter as the fire loaded in. Oh, man. Yeah, look at that. Gas simulations. Woo! Gas simulation tracks density and temperature in a grid as it moves according to velocity fields. This one is 3D, right? Totally 3D fire. 2D fire. Very cool. Fluid simulations. 2D fluid simulation. 3D fluid simulation. I wonder if we can... Oh, can't really walk through it, but it... Look at that. Intro. Explosion. Quality versus performance. This explosion simulates both temperature and density. Values are sourced into the grid. The number of simulated grid cells reduces when you walk on the button. The fewer cells you simulate, the faster the memory. So yeah, this is currently running at like I can feel my frame rate is dropping. When I go over here, low resolution. Super high resolution. Dude, that's crazy. Like full 3D fluid sims like that is insane. And then again, it's also running the simulations in the background. So like go figure, of course, it's lagging a little bit. God, that's so good. Wow, man, yeah. Whoa, custom lighting on the smoke, so the smoke gets its own. Dude, like, my god. Colored smoke. Wow. Wow. Like, dude, that's just so cool. Math at work, dude. Math at work. Smoke and fire.
That's why math's important.
Yeah. This is fire that is forced to face the camera. And it also like approximates, I think, some of the properties in 3D, but only renders in 2D. So I think I remember reading something like that. Ooh, a simulation that follows an object. Collisions. Oh my god.
No way.
2D fluids can have moving collision particles that push the fluid around. Yeah, sick. 2D gas, shallow water. Oh yeah, you can simulate a water surface independently of like the underlying particles, which is really performant. Like games have had this since like Battlefield 3. Waterfall. Nice. Yeah, like, and this example is great because I can just pop out of the editor and click on this and just, right click on this, do find in editor. Where is it? Browse to asset, that's what it is. And then we can open it up and see how it's being done. And this looks like all there is to it. It's like just so cool. Oh god. The GPU hit is immense. Oh, great heavens. Oh, okay. Oh, we're back. Put me in. I think the fact that I popped out of the editor, yeah, there we go. Nice. Constant emission. Oh, a river going down some mountains. Crazy. Very cool. Yeah, so like you see these different levels are organized like these museums, and yeah, they're really good. They're really freaking good examples. This one's not very well documented. Some of the other ones are incredibly well documented. Like if you go to just the last thing I'm going to show you, I swear to God, the last thing. If we go to multiplayer, so I actually need to study this a little bit. I think I'll study this before I head out for gym tonight. This map breaks down all the different details of like multiplayer, and it actually asks you to play this game. See on the play drop down, set the number of players. So instead of hitting play, we're gonna do number of players 2 and hit play. And now it actually popped up another screen on my other monitor. So this is simulating another instance of the game. So we got one instance walking around here, server, and then over here, also server, evidently. That doesn't seem right. Oh, I forgot to hit this, sorry. You don't do a number of players, you do play as listen server. And what this is going to do, there we go. One is the server, one is the client. There we go. So now we have a client. Client's over here. There's the client. See, there I am. That's me standing over there.
Okay.
And then actor replication. This example demonstrates the use of the replication boolean. So like you can learn a lot by just popping out here and being like, wow, look at that. The server can see I don't know if I need to be in game for this. The server can see both of the ghosts, but the client can only see the ghost on the right, because this one doesn't have actor replication enabled. This one has replication enabled. So the server is replicating its properties to all of the clients. Whenever you see the word replication, detecting network authority and remote clients and blueprints. So, interesting. This shows that the server can identify that we're looking at it from the server, but the client sees a different ghost, and we can see like, okay, what's going on? How is it doing that? Well, if we click on the ghost blueprint, and we do edit blueprint, we can see it simply checks has authority. That's it. That's how you do this. You do this switch. Are we on the server or on the client? If we're on the server, execute this code. If we're on the client, execute this code. Like, it's, it's just introducing...
So they're like representing permissions just through like different colors.
Yeah, exactly. Just a way to identify if we're a server or a client, because the server has authority. Here, variable replication. In this example, the ghost's health is being modified on a timer exclusively on the network authority. In the non-replicated ghost, the remote machines never receive updated health values. In the replicated ghost, they receive updates as the server changes the health. So, no replication. Very cool. Like, and see, I'm just hitting Shift F1, and I get to just grab my other soul, move around. Like, oh, and this explains like how the actual code works using rep notify. So if we click on this and we do edit in BP, look at that. Look at the nice comment. Like, it just tells us exactly how everything works. If it's on authority, then periodically set this variable and do it with notify. So there's like a checkbox somewhere over here that's being used. Replication, rep notify. So notify the server that this has changed with this dropdown. And yeah, it's showing that if you set a variable with this thing checked, then it'll be replicated and call an event on the client. And for the client, when a notify is called, this gets executed. So both the server and the client, the variable changes, but when the variable changes, it calls this function, and this is where the actual color changes. A notify is called on both the client and the server, and this gets called on the client and the server. Like, yeah, I love these examples because they're so well made. Like, I actually feel like I can, take away from this and be like, okay, this is the node that I need to use. Like, freaking love Unreal. No one is allowed to say Unreal is poorly documented. That was like a trope maybe 7 years ago. But Okay. All right. Now I'm done recording. 2 hours. Holy crap.